And good day, Algebra. We're going over CO45, simplifying polynomial expressions. Do you folks remember last year, Mattis, all the Greek, Latin, root words quizzes that you took in lit class? The big kahuna, right? This one actually ties very well into that. Because if you'll notice, all of these terms that we have, they all kind of end the same, right? That can go in the garbage can. Monomial, binomial, trinomial, polynomial, they all end in nomial. Okay, can you put the caret in the garbage? Okay. They all end in nomial, which means like term. Okay? So this section of the word means term, and it's the prefix in front that's going to tell us what type of term it is. Yesterday, we talked about the prefix mono, right? And what does the prefix mono mean? Okay, 1. So a monomial is an expression with one term. Okay, an expression with one term. And what separates terms in a mathematical expression? Parentheses, not necessarily. Exponents, no. You're on the right track though, as far as operations. It is addition and subtraction separate terms. Okay. Addition and subtraction separate terms. So when we have some examples of one-termed expressions, some monomials, folks, in the future, these cups can stay in the cafeteria. You don't need them here. If you have a water bottle, you can bring a water bottle, but we don't need those plastic cups. So an example would be something as simple as a constant. 6 is a single term. If we have something like negative 8n, we've got a variable, that's still a single term. There's no addition or subtraction in it. If it has an exponent, such as 14x cubed, that's still considered one term. Or even if it has multiple bases, right? If we have negative 21x cubed y to the 5th, that is still a monomial because it is considered to be one term. What separates terms is addition or subtraction. Okay? So all of those would be examples of single terms. Binomial. What does the prefix bi mean? 2. Okay? Think bicycle, right? 2 wheels on it, right? And so a binomial is an expression with 2 terms. Okay? Which means it's got to have some addition or subtraction in it. So an example of a binomial might be as simple as n plus 1. Doesn't look very complicated, and it really isn't, but it comes down to how many terms does the expression have. And because it's got that addition in there, which separates the n and the 1, it's a 2-term expression. Who's got another example of a binomial? Yeah?
52 minus x.
52 minus x is a binomial as well. Anyone else? We can make them kind of complicated. We can say something like 8x squared y to the 10th plus 17n, right? That's a binomial as well. Or how about something like this? What if we had 3x squared plus 12x? 3x squared and 12x, can those be combined with addition? Yeah. They can't be, actually. Why not? Why are they not like terms? The exponent, right? In order for terms to be able to be combined with addition or subtraction, they have to be like terms, meaning they need the same variable and the same power. X squared and x are different values, so we couldn't say that we have 15x squared, because we don't. We have 3x squareds and then 12x's, but those two things are different. So that would be a binomial as well. Prefix tri. What does tri mean? 3, right? Triangle, 3 angles. trimester. You've got 3 of them. Okay, so a trinomial is an expression with 3 terms, such as, for example, 4x squared minus 10x plus 7. That would be an example of a trinomial. What?
1 plus 1 plus 1.
So 1 plus 1 plus 1, since we can simplify that to be 3, those terms are combinable. That would actually be a monomial because you don't want to classify something until it's in simplest form. So 1 plus 1 plus 1 wouldn't work. However, if we had something like 1x plus 1y plus 1n, since those variables aren't combinable, they're not like terms, that would be an example of a trinomial. Anyone want to throw out one more just for? Oh, how about MATH plus IS plus FUN? That would be a trinomial. Oh, come on. Come on. My livelihood here. Polynomial. What does the prefix poly mean? Anyone know? 4. It could be 4, or it could be.
4 or more.
It basically means many. Okay. If you think of the game Monopoly, and you break that word down, mono, poly. The objective of Monopoly is to be the one owner of many, right? You want to be the one person who owns everything. That's kind of the goal, okay? And so Monopoly, that word poly means many terms. In this case, we would typically say an expression with 4 plus terms, 4 or more terms. Okay? Expression with 4 plus terms. Technically, these are all polynomials that we have here. Like if someone referred to n plus 1 as a polynomial, they wouldn't be wrong, right? Just like if someone referred to a triangle as a polygon, they wouldn't be wrong. But because it has a more specific name, like if you see a 3-sided shape, you could call it a polygon, but it's really a triangle. Okay, both are correct, but triangle is more correct. N plus 1 is a polynomial, but it's more correctly a binomial. Okay, so when you're classifying these, don't just put polynomial for all of them. Be specific. If it's 3 terms, 2 terms, or 1 term, use its most specific name. Okay. And some examples. 4 plus terms, you can have something like 3y to the 4th plus 8n plus z plus 9. Right? 4 terms there. These get pretty long because the thing about it is you can't combine them. There's no like terms here to shorten it up. Another example, negative 12x to the 5th plus 4x squared minus 11x plus 1. 4 terms there, even though we have multiple x variables, they still can't be combined because x to the 5th is different from x squared. And you can write your last one in if you would like to. Good so far? Questions? Anything? Okay. And then to write a polynomial in standard form, which basically today's objective is going to kind of focus on taking a nomial, combining like terms, writing it in standard form, then classifying it. To write a polynomial in standard form, first thing is you want to combine all the like terms. Okay? Kind of like Johnny's 1 plus 1 plus 1 earlier. If you can combine it, do it. Okay? So combine all like terms first, and then here's the kicker for standard form specifically. You want to order the terms in greatest to least exponent order. Okay? Order the terms in greatest to least exponent order. Greatest to least exponent order. So just kind of show what this looks like. We're going to skip down to this one here. Okay. We have 2n squared plus 5n to the fourth minus 8n plus 4n cubed plus 10. Are there any like terms that we can combine? What?
All the ends.
So why can't we combine all those ends, actually? Because they've got different powers, right? Same variable, same power in order for them to be combined. So in this case, there aren't any like terms combined, but now we have to put them in greatest to least power order. And so we've got an exponent of 2, exponent of 4, exponent of 1, even though it's not written. We've talked about that before. It's like there's that invisible 1 there. We have an exponent of 3, and then we have a constant. Okay? Which term would come first if we're putting this in standard form? Yeah. The constant will come last because that doesn't have a power at all. Okay? It's as if it's got a power of 0. We could write that as 10n to the 0 power, because remember, anything to the 0 power is just 1, right? So it's like it's not even there, just have 10, okay? But don't be confused with coefficients and exponents, right? What's the greatest exponent that we have here? 5n to the fourth. Looking at our exponents, 4 is the greatest one, okay? What would come next? Burgess.
4n to the squared.
4n cubed,
Oh, yeah.
or to the third, okay? What would come next? Jeffrey, with a half hand up. What's the next greatest power that we have there?
2n to the second.
There you go. 2n squared. And what would come next? Okay?
Negative 8n.
Excellent that you included that negative sign, right? It's that sign belongs to the term, so you write minus 8n. And then lastly comes the constant. Okay? And if you'll notice, these powers are written in 4, 3, 2, invisible 1 there, and then nothing. Okay? Greatest to least power order for standard form. And then what type of nomial is this? Mono, bi, tri, or poly? Poly, because it's got 4 or more terms. There's no specific name for anything that is beyond that. All right. So let's just kind of go back to the top now. 12x cubed plus 3x cubed. Can we combine those? Yeah. How many x cubes do we have in all? Not 6. Not 9. 15. Remember what a coefficient does. A coefficient tells us how many of something we have. We don't know what x cubed is, but we know that we have 12 of them. And then we get 3 more of them. Right? So we start with 12 of something and get 3 more of something. We have 15 of that something. Okay? Combining like terms like this is very similar to adding and subtracting fractions. Right? If we had something like, I'm just going to make up a denominator here. So if we had something like 12 11ths and 3 11ths, we could add those because the denominators are the same and the denominator doesn't change. Right? When we add or subtract fractions, it's just how many 11ths do we have? We have 15 of them. Same kind of thing here. Whatever x cubed is, we don't know. We don't really care. But we have 12 of them. We get 3 more. Total, we have 15 x cubes. The exponent doesn't change. Okay? Because all we're doing is getting more of the same thing. 15 tacos and 3 more tacos doesn't give me, or 12 tacos and 3 more tacos doesn't give me 15 super tacos. They're just tacos. Delicious, but just tacos. Okay? The exponent does not change when we combine like terms. And then what type of nomial is this? Monomial. Jack, was your question about the powers?
Yeah, because doesn't the other PO we did that has like all the rules, doesn't that say to multiply them?
Yes.
1 to 2.
But that whole unit, CO10 through CO15, where we multiply powers, we were using the operations of multiplication there. This is the operation of addition. the rules are different when you add or subtract something from when you multiply or divide them. Just like with fractions. If we had 12 11ths times 3 11ths,
Then you just multiply.
then you multiply the denominators too, though, right?
Right.
They change. With addition, they don't. Okay? With like terms here, when we add, we don't change the power, but if we had 12x cubed times 3x cubed, then you're right. In this case, we would get 36x to the sixth. The powers would add there. Okay? So because we're adding and subtracting combined like terms, the rules are a little bit different from all the way back in PO 15. This just tells us how many of something we have. Okay? You'll find that all throughout math, that the rules for adding and subtracting are different than multiplying and dividing. Okay? Next one, 14n to the fifth minus 4n to the fifth plus 2n to the fifth. Think of that n to the fifth as just an object. It's something. We don't know what it is. We don't really care. But we start with 14 of them. We subtract 4, and we get 2 of them back. When all said and done, how many do we have?
8 or 12.
One of those. 12. Okay? 14. We take away 4. That's 10. We add 2 back. That gives us 12. Our exponent doesn't change because we're combining like terms. We're not multiplying all these terms together. We're adding them and subtracting them. So it's just how many n to the fifths we have. And what type of nomial is this? Monomial. It's got a single term. Right. Next one, 5xy squared plus 10xy squared minus 12. Any like terms? Same variable, same power. K, what?
5xy to the second power, 10xy to the second.
Yeah, how many xy squares do we have in all?
4. Or 15.
15, right? We start with 5, we get 10 more. Total, we have 15 of whatever xy squared is. And then minus 12 being a constant, we can't combine it because it does not have an xy squared with it. And so we would leave it as is. And what type of nomial is it? Binomial. Yeah.
I'm a little ahead, but for the second one in the third row, would you just do the negative? Would you just subtract the two, or would you switch them so that it would be a?
Let's finish out the row, then we'll jump down to that one, so that we can all get it. Okay. The last one in the row: 7y minus 3x plus 12x minus 2y. What like terms can we combine? Heavy.
The 7 and negative 2y.
Good. The 7y and the negative 2y. Don't forget that sign belongs to it. So how many y's do we have after we combine the 7 and the negative 2? 5. Okay. And what about those x's there? We have a negative 3 of them. We get 12 of them. How many x's do we have total? 9. Negative 3 plus 12 equals 9. Now notice I kind of adjust this a little bit. I put my 9x first. Okay. X and y both have the same power, right? It's x to the first and y to the first. So when that happens, our kind of guide here was put the powers in greatest to least order. If they're both the same, then you go alphabetical by variable. Okay. So because x comes before y in the alphabet, 9x would come before 5y when writing it in standard form. So your first check is the powers, greatest to least order, like we did here, 4, 3, 2, 1, constant. If they're the same, then you go alphabetical. And there's one more caveat to that we'll get to, no, maybe we won't, on this page, but future pages. Okay. Shay, you had your question on the middle one in the third row, 8x squared plus 4x minus 18x plus 7. repeat your question again?
Do I keep, so there's 4x minus 18x. If I were to combine them, would I switch it so that it would be 12x, or would I keep it negative?
Well, it's whatever it works out to be. What is positive 4 minus 18?
Positive 4 minus 18.
A 14, negative 14.
Negative 14, right? If you have 4 something, you subtract 18 from it, you have negative 14 of that something left. So our x squared, which we can't combine with anything, because that's got a power of 2, those x's don't, right? They're a power of 1, so not like terms. But then we get negative 14 of them, and they're a constant plus 7. So 8x squared minus 14x plus 7. Notice our powers, power of 2, power of 1, constant. They're in greatest to least order. And so that would be standard form. And what type of nomial is it? Trinomial. Okay? Questions on any of this? Abby?
So for the one above that, did you go 10 minus 1?
For combining the x to the fifth?
Yeah.
You're saying? Yeah. So for this one, we've got a positive 10x to the fifth, and we're taking away an x to the fifth. Remember, even though it's not written, it does have a coefficient of 1. So it is like 10 minus 1. Okay? Yes, you are correct there. The rest of this page, I think we can just have it be for homework for tomorrow. You got 4 of them left to do. Don't forget to label them, combine like terms, put them in standard form, all of the things. You've got about 5 minutes to do it now, folks. I think we have an excellent opportunity for the number game tomorrow. Excellent opportunity for the number game tomorrow. It's been a long, long time. I think we can do it. Okay, homework for tomorrow. That's it, math. Thank you.